Hey, and welcome back to Gaffy's Grinds. In this video, we are going to discuss the effect that it has when we dilute a solution and measure its effect on its concentration. So we're going to start by looking at an example like we usually do. Let's say here we have a glass of orange squash. So we've looked at an example like this before, orange squash, something like my body. And we know that this orange squash here, this solution of orange squash, has a certain number of moles in a certain volume. This is our original solution. We haven't done anything to it yet. We just have a solution. It's got a certain number of moles and it's got a certain volume. Now, let's say, for example, that we then take that solution and we add some water to it. So we add some H2O. I think you'll recognize that in this case, the number of moles stay the same because we have not added any extra moles of solute. Remember, the moles refers to the amount of solute. So we haven't added any more solute. However, we have changed the volume of the solution. We've made the volume of the solution get bigger. So the volume of solution has gone up. So what effect does this have on concentration? Well, let's say, for example, we have in the first case, we have 1 mole of solute. Let's let our moles on top be 1. And our volume, we won't define it as any unit, but we'll just say it's 1/3 at the moment. Add more water to it. What have we done? Well, we still have 1 mole because we haven't added any extra moles of solute. However, what we've now done is we've made the volume of the solution increase, say, up to 4. If we think about the decimal numbers for these fractions, 1/3 is 0.33 and 1/4 is 0.25. So we see that by increasing the number in the denominator here, by putting that number up, we have decreased the size of the fraction, or in other words, we have decreased the concentration of the solution here. Now, if we think in terms of the original solution, in the original solution, we would have had an original concentration in moles or molarity. We would have had a certain amount of molar. So we would say maybe we have a concentration 1, and it's also a certain volume of solution. So we might say we have a volume 1. Now, the reason why I'm saying 1 is because this is the first or the original concentration. Now, of course, what we've done by adding when we add the water is we've made a new solution. So in blue here, we now have an M2. We have a new concentration. And usually we know that that's going to go down, just like it did here, because we've added in extra water. But we also have a new volume. We have V2. By adding more water, we've made the volume change as well. So how do we think about this in terms of solving problems? Well, there's a couple of ways we can do it. Let's say we take a problem like this. I'm going to get you guys to pause the video and read it carefully. Apologies now, I just need to pause the video for a second. There's a couple of ways we can tackle this problem, okay, and we can tackle it using unit analysis and first principles methods, like using unit analysis, but it is quite difficult and complex here. So I usually like to go through the unit analysis and show you how things work. And if you think you can figure that out, then brilliant. By all means, have a go with it. But it is quite complex. So there is this pretty simple formula method that works well here as well. And I'm going to show you that formula method here. Do you remember what we said up here? That the original concentration would have been M1, a certain number of moles, and it also would have had a certain volume. So M1 and V1, both of these will give us the concentration of the original solution, the number of moles and the volume, moles by volume. And the formula here is that M1 times V1 is equal to M2 times V2, M2 times V2. Okay, now let's just clarify these things. Okay, so what do these stand for? M1, original conc, usually moles per liter, volume. And this should be in liters. And then M2 is equal to the final volume, final concentration, sorry, conc, where M stands for molarity, of course, and V2, that should be blue, V2 equals final volume. Okay, so I'm going to get you guys to pause the video and make a note of this if you like. This is a equation to calculate the effect of dilution. So you can put a heading on it to calculate the effect of dilution of a solution. And this is a 4-variable equation, and we know how to rearrange it, but we're going to show you this using an example problem. Now, let's have a look at this problem here, and we are going to try and identify variables here. So the first thing I see is it says if 100 centimeters cubed of water is added, to 150 centimeters cubed of a 0.4 molar solution, what will the new concentration be? All right, so the first thing I notice is here is that this is the original concentration, the original solution, 150 centimeter cubed, and it's 0.4 molar. So this here is going to be what we call M1, the original concentration, moles per liter. And this here is going to be V1, the original volume. But that's in cm cubed, so I need to convert to liters first. Now, I've shown you how to do this before. You do 150 cm cubed times by 1 liter for every 1,000 cm cubed equals, so cancel out cm cubed, and you're going to get 0.15 liters. Now, most of you may be able to do that in your head because you've done it so many times that you know how to do that in your head. So this is going to be 0.15 liters. Now, we know M1 and we know V1. Now, it says if 100 centimeters cubed is added to that, so there we can work out V2. Now, V2 is not going to be 100 centimeters cubed because V1 was already 150 centimeters cubed, and we're adding 100 more. So V2 is going to be this original concentration plus another 100 mils, which gives us 0.25 liters. So now we have V2, V1, and M1. Okay, so we're missing one variable, which is what we want. We only ever want to be missing one variable in order to solve it. So let's go ahead and, sorry, I'll get my screen back. Let's go ahead and show you how we solve this. So we begin by writing down our formula. We just learned that it's M1 times V1 equals M2 times V2. All right, so very simply, we need to try and isolate one variable. Now, the one variable that we're going to be looking for is M2. It says find the concentration, M2, of the dilute solution. So this one here is what we're going to try and isolate. So we're going to try and isolate this. Now, currently, M2 is being multiplied by V2. So I want to remove V2 from that side of the equation. So I'm going to divide by V2. V2 divided by V2 gives me 1. And then I'm going to do the same on the other side because of the equal sign. I have to do the same on both sides. So I'm going to divide this side by V2 as well. And now I've got an equation with M2 isolated. So M2 equals M1 times V1 over V2. Now I'm going to go ahead and plug in my values here, and I should get the right answer there. So M2 is equal to, I'm going to sub in, M1 was 0.4 times by V1, which was 0.15. Remember to do this in liters. All over the V2, which was 0.25. Go ahead and get your calculator out now and do this sum. We're going to get 0.24 moles per liter. Okay, so that is my final concentration. And that makes sense because it was originally 0.4. We added more water, so we diluted it. So this number should be less, and it is. Okay, so now that we've had a look at that and how to do that, sorry, I'm going to pause the video. I'm going to get you to pause the video, have a good look at this and study it. Take it down if you want to as a model example. And then you guys are going to have a look at this one for me. Pause the video and do this now. Okay, so what you should have done is begin by, so if you weren't able to start, let's begin with the formula. What is it? It's M1. Oh, sorry, no, we won't. We'll begin by labeling. Okay, so I'm going to label this here as M1. This is my original concentration. And my final answer is asking what will the concentration of the diluted solution be? So this is going to be my M2. My original volume is V1, and that's equal to 0.15 liters again. Okay, so 150 centimeters cubed, 0.15 liters. It says I'm adding 50 cm cubed. So my V2 is going to be my V1 plus another 50 centimeters cubed. It's going to be 0.2 liters. Okay, so now we're going to go to our formula. It's M1 times V1 equals M2 times V2. Okay, and we want to isolate M2 again. So pause the video. I'm going to divide both sides by V2. Now you have your formula. You're ready to plug in your variables. So plug them in and find your answer if you haven't done this already. So I'm getting M2 equals M1 times V1 over V2. equals M1 was 0.3 times by D1, which was 0.15 all over 0.2. And I'm going to get my calculator out, have a go at doing this. 3 times by 0.15 divided by 0.2. I'm getting 0.225, and of course that's in moles per liter because it's concentration. All right, so now that we've had a go at, I've done one, I've helped you with one, maybe you're ready to do some by yourself now. Okay, so I'm going to get you guys, oh, sorry, it's going again. I am going to ask you guys to have a go at questions 17 to 19 here. Okay, so pause the video, have a go at questions 17 to 19. Okay, so you should have had a go at them now, and hopefully they are pretty straightforward, I think. The only one I would say to you is with number 18, you got to be careful because you're not looking for M this time, you're looking for a V. Okay. All right, so we will go through those questions in class the next day. I'm hoping that those were pretty straightforward for you. And we are going to have a look at some other examples. So let's move down to this one. All right, so I'm going to get you guys to pause the video and read this problem. Okay, now this case is asking you what volume must be added. Okay, must be added. It's not asking you what the final volume will be. So it's asking you to find what volume was added. So to do this, if you think about it, you're going to have to find the final volume, the original volume, and find how much was added to make the final volume, if it makes sense. So you're going to have a little extra step in this one. If that makes sense to you and you're ready to pause the video and have another go, have a go at this, I would advise you to pause the video and do it, because if you can do it yourself, that's better. All right, if not, then let's talk about this together. All right, so first of all, let's see what we know. We know that we have a 1 molar solution. So this here is going to be my M1. So that it then has a concentration of 0.1. So I'm changing the concentration. This is going to be my M2, my second concentration. Here was my original volume, V1. So what I'm setting out to find is V2. Now I know my original volume was V1, 25. If I then find my final volume, then I can find the difference between these to find out how much I added. So if I go back up to my picture again, it's kind of like this. I have my original volume in orange. I then added some water to make my final volume, which is this here. The question is, how much is the blue? How much is just the blue bit? How much did I add? Because this thing here shows me the total volume at the end, V2. And I don't want to know that. I just want to know how much water did I add. All right. So we still have to go ahead and find V2 the same way as before. There's just another thing to think about afterwards. Okay, so what we're going to do is we are going to go ahead and write in our equation. It's M1 V1 equals M2 V2. By the way, you'll notice that this time I'm not writing the multiply signs. It is the same thing. Without writing the multiply signs, when you write it like this, M1 and then another letter straight after, another variable, you assume it's multiply. Some people, it's just sometimes a bit tidier not to write loads of multiply signs. You have to know it means the same thing. Okay, so M1 V1 means the same as M1 times V1. I know I've told you this before, but I'm always reinforcing that idea. All right, so what we're trying to do is isolate to find V2. So what we're going to do is we're going to divide by M2 on the right to get rid of it and leave V2. And I'm going to do the same on the left, M2. So now I'm rewriting it as V2 equals M1 V1 over M2. All right, plugging in my values, what I get here is V2 equals M1 was 1 times by V1 was 25 all over M2 was 0.1. All right, so I am going to go ahead and do that calculation. 1 times 25. Oh, of course, that should be. Oh, yeah. No, I'm okay because it asked me to find the answer in centimeters cubed. Yeah. So I'm going to put this in centimeters cubed. So 25. Yeah, 1 by 25 over 0.1 gives me 250 is my V2. So my new volume, V2, equals 250 centimeters cubed. Now I know it's centimeters cubed because I put in this in centimeters cubed. Okay, so V2 is centimeters cubed. Now I wasn't asked for V2. I was asked for how much water that was added. Okay, to get the water added, I must take my final vol, which is V2, and take away my original volume, which is V1. So in this case, I have 250 centimeters cubed, the final volume. I'm going to take away the original 25 centimeters cubed, and that will give me 225 centimeters cubed. That's the amount that was added, and that's my final answer. So quite a lot of stuff going on there, quite complicated and tricky. But if you really think your way through the problem, it shouldn't be that hard. There's no hard maths in there. It's thinking carefully about the problem and what they want you to do. Right. I'm going to let you guys have a go at this one. Start off by labeling the stuff in the question, please. Pause the video and do that now. Okay, once you have that done, write down the equation and rearrange it for the variable that you want, please. Make the variable you want to find the subject. Pause the video, do that now. Okay, right. So let's see. Here we have an original concentration. So this is M1 and this is V1. That's the original volume with 50 centimeters cubed of that. So 50 centimeters cubed of a 4 molar solution. And we want to add water so that it's now M2. This is the new concentration. So what we need to do is find V2 and then find out how much water was actually added to do that. So we need to find V2 first of all. All right, so then you're rearranging your equation. M1 V1 equals M2 V2. We want to solve for V2. So we want to remove M2, cancel them out, and we want to do the same on the other side. So rewrite it, V2 equals M1 V1 over M2. Now I'm going to go ahead and plug in my values now. M1 was 4 times by V1 was 50 all over 0.2. So when I do that, what I got was I'm getting 1,000 centimeters cubed. 1,000 centimeters cubed is my final volume. My original volume was 50 centimeters cubed. So I want to find out how much water was added. Water added equals my final volume, V2, take away my original volume, V1. So it's 1,000, take away 50. It's 950 was how much was added. Well done if you got this right by yourself, and if you were able to think that all the way through, brilliant. If not, then I suggest you go back and watch the original example again, and now you should be ready to do some questions here. So we are doing questions 20 and questions 21. There should be plenty of practice in there to help you guys master them. Okay. All right, that's it, guys. I hope you found these videos useful. I hope you feel confident about your calculations. We will go through them, the answers the next day in class, and that's it for now. So we'll see you in the next lesson.